This is Mrs. Zappia with Lesson 13, Changing Scales. Student outcomes for this lesson. Given two figures, one a scale drawing of the other, calculate the scale factor. And given the scale factor for drawing 1 to drawing 2, calculate the scale factor from drawing 2 to drawing 1. The essential question for this lesson. Given a drawing and a scale factor from drawing 1 to drawing 2, how do you find the scale factor from drawing 2 to drawing 1? For our opening exercise, first let's review how to find the scale factor when you have two drawings and their lengths are given. The scale factor is a quotient, so you can write it as a fraction. The numerator is the length in the scale drawing, and the denominator is the corresponding length in the original drawing. You'll want to memorize that the scale drawing length goes in the numerator and the original drawing goes in the denominator. Describe using percentages the difference between a reduction and an enlargement. Well, we know that a reduction is where the drawing gets smaller, but the scale factor, that would be less than 100%. And we know that in an enlargement, the picture gets bigger. And so your scale factor would be greater than 100%. Use the two drawings below to complete the chart. Calculate the first row, drawing 1 to drawing 2 only. So we'll take a look at our drawings. We have a box here, and it has a length of 2.45 inches and 1.5 inches for the width. And drawing 2 is a scale drawing of drawing 1, and its length is 3.92 inches and its width is 2.4 inches. So we want to calculate the scale factor. So what we're working on, we're going to write the quotient of the corresponding horizontal distances. And we're going to write that as a fraction because it is a quotient. And we have the length of the scale drawing over the corresponding length of the original. And then you think, well, which one is the original? Is it drawing 1 or drawing 2? So drawing 1 is the original drawing, and you can assume that unless they say otherwise. So we have the horizontal distance, and the horizontal distance of the original is 2.45. So we have 2.45, and then the numerator is the length on the scale drawing, and that is 3.92. Okay, so that's written as a quotient. Now for the vertical distances. The vertical distance of the original is 1.5. And the vertical distance of the scale drawing is 2.4. And then the scale factor as a percent. So what we want to do to write the scale factor as a percent is to convert these two fractions to percents. Remember to convert a fraction to a percent. It's numerator divided by denominator times 100. So 3.92 divided by 2.45 is 1.6. And 2.4 divided by 1.5 is 1.6. And that's as a decimal. So we want to convert that to a percent, and that is 1.6 times 100. And that gives us 160%. And that's our scale factor as a percent. So again, that's numerator divided by denominator times 100. Then, is that a reduction or an enlargement? Well, since our scale factor is greater than 100, that would be an enlargement. Compare drawing 2 to drawing 1. Using the completed work in the first row, make a conjecture or a statement about what the second row of the chart will be. Justify your conjecture without computing the second row. So what we want to know here is this going to end up being a reduction or an enlargement? And we're going from drawing 2 to drawing 1. So drawing 2 is a larger picture and drawing 1 is a smaller picture. And we would expect that our scale factor will be less than 100 because it's a reduction. 1 is smaller. This will be a reduction, and the scale factor will be less than 100%. All right. Compute the second row of the chart. Was your conjecture proven true? So we'll go ahead and complete this now. And we need to fill in our fractions from drawing 2 to drawing 1. Now, the important thing to notice here is that drawing 2 is now our original. And the original goes in the denominator. So we want the horizontal distance, and that is 3.92. And then we want the horizontal distance on the drawing, and that's 2.45. And then we want the vertical original distance is 2.4. And then the vertical distance on the scale drawing is 1.5. So notice that it's the reciprocal of the previous fraction. So again, we do numerator divided by denominator, 0.625 times 100. And the answer is 62.5%. And since the scale factor is less than 100%, we know that this is a reduction. So when we went from drawing 2 to drawing 1, that was a reduction. So we've completed the second row, and was your conjecture true? And yes, our scale factor was 62.5%, which is less than 100%, so it was a reduction. I want to point out in this example, when we were doing the first row, we were starting out with drawing 1 being the original figure. So drawing 1, the 2.45 inches, is in your denominator because that is the original. When we were going from drawing 2 to drawing 1, then drawing 2 is the whole, and so 3.92 is the denominator because that is the original. So remember, what is the whole or the original can change. In the next example, the scale factor from drawing 1 to drawing 2 is 60%. And this makes sense because we see that it is a reduction, so we would expect the scale factor to be less than 100%. So what we want to do now is to find the scale factor from drawing 2 to drawing 1. Again, going from 1 to 2 is 60%. And the question is asking, what is the scale factor to make drawing 1 from drawing 2? In order to calculate the scale factor from drawing 2 to drawing 1, this is the process. It's 100% divided by the scale factor, and then you multiply that by 100 so that you're converting it back to a percent. Okay, so we have 100% divided by 60% times 100. You can use your second FD percent key for this, or you can convert it to decimals and then do the math. So converting it to decimals, 100% is equal to 1. 60% is equal to 0.6. So 1 divided by 0.6 times 100 is equal to 166.6 repeating. Remember when you have a repeating decimal to use your second FD key and convert that to a fraction. So our answer is 166 2/3%. And that makes sense that our scale factor would be over 100% because it is an enlargement when we are going from drawing 2 to drawing 1. Okay, you'll want to memorize how to find the scale factor working backwards. Next, we'll go to the bottom of page 109 to summarize the lesson. In this lesson, we learned 2 skills. The first one is to compute the scale factor when 2 of the corresponding lengths are given. To do that, you write a fraction and then convert that fraction to a percent. The numerator is the length on the scale drawing over the corresponding length of the original drawing. So then you would divide that and then multiply by 100. And the second skill that we did, given the scale factor from drawing 1 to drawing 2, Find the scale factor from drawing 2 to drawing 1. And the procedure for that is 100% divided by the scale factor times 100.